Hi YouTube friends, teachers, homeschoolers, and anyone else watching this video. This is Elizabeth with an S with another science hands-on activity that is going to be about converting stored energy into kinetic energy. If you're watching and you have not yet subscribed to this channel, please do so. Please share my channel and videos with your teacher and homeschooler friends. So that way they can get on board as well. So today we're going to be doing something called the Bebop, and this Bebop will illustrate the concept of converting stored energy into kinetic energy, and all you need is a piece of paper. So this piece of paper should be 7 centimeters long by 3.5 centimeters wide. That's 2 3/4 inches by 1 3/8 inches if you want to be exact. I've tried to get the paper to be the best size to do this. That will give us the best end result. So those measurements kind of work the best with this type of paper, but if you want to make it bigger or smaller, you can choose to do that. So what you're going to do is you need to measure two things from either end. You need to measure 1.7 centimeters or 11/16 of an inch from either side. So that is 17 millimeters. I'm just going to measure that there. There, and do the same on both sides. So this is something simple that you could probably have cut out ahead of time. So, 14. Let's see. And you could just draw a little line, light line, so the lines are marked. Anyway, so you could have this cut out ahead of time, so that way your students wouldn't need to do that unless, of course, you want them to cut it out ahead of time. So what you're going to do is you're going to take the paper and fold it along this line on one side. Okay, and you don't have to fold it, don't have them like fold it down so it's so tight. You want to leave the fold loose. And then you're going to turn it over and take the end of the paper and fold it back up to the end, just like this. And again, you want to leave it so it's kind of sticking up like that. So it doesn't need to be folded down. It should just be folded so it sticks up. Now for the other end, what you're going to do is actually cut this into a semicircle. So, and if you want to, you can outline it for your students and do that ahead of time or have it already cut out. But there you go. Got your semicircle. And then what you're going to do is fold it over, and going to do a couple more folds. So let's just mark sort of the center of that. You can just eyeball it. And you're going to do a couple folds. You're going to do one fold on one side like that. Okay, so this fold should go from the center of the top all the way to this line that you've made. So you can see there, that fold is like that, and this one will be like this. Doesn't have to be exact, but just the general idea. That can be folded down fairly tight, and then you'll just bring the middle point down like this, and you end up with something like that. Now you can erase this line, and then you have your Bebop, which is supposed to be a little frog. So now what's going to happen with this is your Bebop, and you can actually have your students decorate this once they've finished it. They can decorate it so that way it kind of looks like a little frog, and then something like that. So I've just put eyes and a nose on there. And so all they need to do is use their little frog and their finger. And you, whoops, that's called a turtle. We don't want that to happen. Okay, and just have your little frog jump, just like that. And you could have your kids race their Bebops a certain amount, see who gets there first. If their Bebop does that, it's a turtle and they are out of the game, maybe. So no turtles are allowed at the Bebop race. So that's just something you can do kind of just to play with the toy after. But basically this double fold here is going to act like a spring. When you press it, the force you apply is stored as elastic energy. When it's released suddenly, like when you lift your finger like that, the energy is converted into kinetic energy and the Bebop will leap up and move forward. So you can try this with different types of paper to see. So I've just used regular photocopy paper. You can try this with thinner paper, construction paper, craft paper, all different types of paper. See which one works the best if you want to turn it into a science investigation. You can try cardboard and see if that will work as well. If it doesn't, you can discuss why it does not work, as far as the stored energy not being enough or the kinetic energy not being enough to move the Bebop forward. So that's just a very, very simple hands-on activity that you can do that is really, really cheap because it just requires a small piece of paper, pencil and scissors, and maybe some markers to decorate their frog. So hope you've enjoyed this video that shows how to convert stored energy into kinetic energy. This little Bebop. And once again, this is Elizabeth with an S. Hope to see you next week with another science hands-on activity that requires small, inexpensive supplies.